Okay, so today we're going to talk about how you change improper fractions to mixed numbers. Now, many students have been given a shortcut method to use. For example, if they're given the improper fraction 9 halves, they're told, well, do 2 goes into 9 how many times? Let's do it over here, actually. This is the algorithm method. They're told to divide. So 2 goes into 9 4 times. That's 8. 1 left over. Then they're not really sure what to do with that, but they're told put that on the top, get 4.5. And that's true. That's exactly what 9 halves would be as a mixed number. So if that method makes sense to you, if you know why it works, go for it. It's a great way to do it. Here's what I've learned. Most students don't know why that works. So we're going to explore the why here. Because again, as we've talked about in the past, you will understand mathematics better if you understand why things work. So here you go. Let's start by taking the halves, and we're going to draw ourselves a rectangle divided into 2 parts. That's enough to have one whole right here, which is 2 halves. Well, if all we needed was 2 halves, that would be plenty, but we need 9 halves. So we are going to draw some more of those same rectangles. Now, I have the advantage of this wonderful tool for duplicating things, so each one looks exactly like the last one did. You might not have this available to you. By the way, feel free when you do these types of things, if you have a tool like this that I use and it makes it more engaging for you, feel free to do that. If not, just quickly draw the rectangles in your spiral. All right, so now we're going to see if we have enough of these to do 9 halves. So 1, 2, 3, 4, 5, 6, 7, 8. We came up a half short, so we'll need another one of these rectangles. And if we shade that, now we have our 9 halves. So let's see if that matches our 4.5. We had 1 here, 1 more here, 1 more here, 1 more here, and a half. We have 1, 2, 3, 4, and a half. We can count them out. 1, 2, 3, 4, and a half. So there's a method for seeing why 9.5 equals 4.5. Let's look at one more method. One more great thing to do is the idea of subtraction. That's what division is. Division is just repeated subtraction, just like multiplication is repeated addition. So let's look at this from a subtraction standpoint. Let's take our 9 halves, and let's take away 2 halves. That 2 halves is 1 whole. 9 halves take away 2 halves. Remember, anytime you are doing subtraction with fractions, you have to have the common denominator. We've got it, the 2's, and then all the action happens in the numerator. If you need a little reminder of that, here's your little reminder off to the side. Remember, 9 halves take away 2 halves is really 9 minus 2 over the 2. All the action takes place in the numerator. All right, are there enough halves left to take away another 1 whole? Well, sure. We have 7 take away 2, and now we have 5 halves, and we took away another 1 whole. Can we do that again? You bet. We still have enough, so we're going to take away another 2 halves. That's going to leave us 3 halves, and there is another 1 whole we took away. And yes, we can do that again. 3 halves, take away 2 halves, leaves us 1 half. There is another 1 taken out. And now we have less than a whole left, so that's the amount we have left. And if we add all of these together, we get 1, 2, 3, 4, and a half, which is exactly what we got doing all these other ways of looking at it. So that's the why it works. Again, What we don't want to do is we don't want to have rules, these things we call algorithms, that we learn the algorithm, but we don't know why. And because we don't know why, if it goes wrong, we don't know where it went wrong. We can get wrong answers and not even realize they're wrong answers. On the other hand, if we know why it works, then we're much more likely to come up with the right answers, or if we get the wrong answer, to know that we've made a mistake. Okay, so let's go ahead and try another one together. Let me jump over a page here. And let's try, how about 8/3? We're going to change that into an improper fraction. That is an improper fraction. We're going to change that to a mixed number. So let's start with our boxes. So we have a box of thirds. And we have another box of thirds. I'm going to keep track of my thirds so far. That was 1, 2, 3, 4, 5, 6. I still need at least one more. 7, 8, 9. All right, I have enough to do 8/3 down. Remember, each of these boxes is 3/3, which is 1 whole. So here are 1, 2, 3/3. 4, 5, 6/3, that's another 1 whole. 7/3, 8/3. I have 1 plus 1 plus the other 2/3 left. 1, 2, and 2/3. My 8/3, I'm saying, are equal to 2 and 2/3. Let's check that out with our subtraction method, see if it still works. I've got 8/3, and I'm going to take away 3/3. That's 1 whole. 8 take away 3 is 5. I've got 5/3 left, and that's enough to take away another 3/3. So I could take 3/3 away again, and I am left now with 2/3. That's less than a whole, so I bring it down. 1 plus 1 plus 2/3. There is the same 2 and 2/3. All right, let's try that division algorithm and see if it gives us the same answer. If we take our 8 and we divide it by 3, 3 goes into 8 twice, that's 6. We have 2 left over. Now the important thing to remember is that this 2 right here on top, that's the whole number part. What's left over is the fraction part. So 2 full times and 2 more thirds. So 2 and 2/3. This gives us 1, 2, 3 different ways of seeing that 8/3 is equal to 2 and 2/3. And if you remember, if you caught way back up here, if you were saying, wait a minute, he wrote the wrong thing, you were right. Should have been a 3, not a 2 all along. All right, let's try one more of these. Let me just shrink this up and move it out of the way a little bit. And let's do one more over here. So I'm going to give you a problem. I'm going to give you the problem 23/5. 23/5. Now what I'd like you to do is pause the video and do 23/5 all 3 ways. Do it with the rectangles. Shade them in. See what you get. Do it with the subtraction. Do it with the division. So that you fully understand the 3 different ways this works, which will help you know the why it works. So go ahead and do that, and then we'll go through it together. Okay, 23/5. So let's start out with our rectangle method. So I'm going to need rectangles divided into fifths. I'm always dividing based on what the denominator is. And I'm going to use my handy duplicating tool here. Let's see if I can get this to duplicate just that. So there's 5/5, 5 more, that's 10/5 so far. 15 fifths, 20 fifths, 25 fifths. And I only need 23 fifths. Each one of these that I shade in, each of these, if I shade a whole thing in like so, that's 5 fifths, which is one whole. So 5 fifths, 6, 7, 8, 9, 10 fifths. There's another one whole. 11 fifths, 12 fifths, 13 fifths, 14 fifths, 15 fifths. 15 fifths, by the way. Let me just find a little corner of the world here. 15 fifths equals 3 wholes so far. 16, 17, 18, 19, 20 fifths, 21, 22, 23. So my last one doesn't fill the rectangle, so that's only 3 fifths worth. So I have 1 and 1 more and 1 more and 1 more and 1 more and 3 fifths. 1, 2, 3, 4, and 3 fifths. My rectangle method tells me this should be 4 and 3 fifths. I'm going to use my subtraction method to confirm that. So here we go. Using the subtraction method, I've got 23 fifths, and I'm going to take away 5 fifths. 23 take away 5 is 18 fifths, and so far I have one whole. I can take away another. I got plenty of fifths left to take away. 18 take away 5 is 13 fifths and another one whole. 13 take away 5, 13 fifths take away 5 fifths. Remember all the action. If I'm doing 13 fifths take away 5 fifths, all the action is happening in the numerator. 13 take away 5 is 8 fifths, and I've got another one whole. 8 fifths take away 5 fifths is 3 fifths. All right, I'm done taking away because now what I have left is less than one whole. Remember, to be one whole, it has to be 5 fifths. So I have 1, 2, 3, 4, and 3 fifths, just like I had here. So that's the first method. Do the rectangles. The second method, do the subtraction. Now comes the third method, do the division. And I'm going to do my division, and I'm going to have my 23 divided by 5, except that I'm going to show it as a long division problem. 5 goes into 23 4 times. There's my whole number 4. That's 20. 3 left over. There again is my whole number 4 and my 3 fifths. And my third method confirms it as well. All right. I've got a couple more problems for you to try. And I'd like to see you using all the methods. So I'm going to show you some problems, and I'd like you to use all 3 methods to change the improper fractions into the mixed numbers. All right, so here are a couple of problems for you to try. 17 fourths and 28 sixths. So remember, you're using all 3 methods. You're going to do the rectangles. Let's go back and look. You're going to do the rectangles. You're going to do the subtraction, and you're going to do the division algorithm. This is the standard algorithm. It's eventually where you'll end up. But when you get there, you'll understand the why. That's an important part here, is understanding the why it works. So there are your problems. Go ahead, work through those, and then you can turn the video back on. You have 2 choices. You can work through the 17 fourths, turn the video on to check your work, and then do the 28 sixths. Or you can do them both and then turn the video on to check your work. Okay, get to it. All right, let's take a look at how you did. So here are my rectangles ready to go. Each of these is 4/4, and that 4/4 is equal to 1 whole. So 1, 2, 3, 4. Remember, my target is 17. So 1, 2, 3, 4, 5, 6, 7, 8. There's another whole. 9, 10, 11, 12. There's another whole. 13, 14, 15, 16. There's another whole. And 1. 1 out of 4. So I have 1, 2, 3, 4, and 1/4. So it looks like 17/4 is 4 and 1/4. Let's check with our subtraction. So 17/4 minus 4/4, there's my first 1 whole, equals 17 minus 4 is 13. So I've got 13/4. That's enough to take away another 4/4. There's another whole. 13 take away 4 is 9/4. I can take away another whole. There's another whole I'm taking away. That equals 5/4, which is enough to take away another whole. One more whole taken away. And that equals 1/4. So that's where I have to stop because I'm down now less than a whole. So 1 plus 1 plus 1 plus 1 plus a fourth. 1, 2, 3, 4, and 1/4. All right, last method is the division algorithm. Take the 17, divide it by the 4. 4 goes into 17 4 times. That's 16. 1 left over. So my 4 and my 1/4. All right, if you didn't do the 28/6 yet, go ahead and do that now and then turn the video back on and we will go over that one. All right, so let's take a look. I've drawn my rectangles out. Remember, for each of these, each rectangle is 6/6, and 6/6 is equal to 1 whole. So let's start shading. 1, 2, 3, 4, 5, 6. 1 whole. 7, 8, 9, 10, 11, 12. Another whole. 13, 14, 15, 16, 17, 18. Another whole. 19, 20, 21, 22, 23, 24. Another whole. 25, 26, 27, 28. So the last one had 4 parts out of 6. So if I add these together, 1, 2, 3, 4, and 4/6. 4 and 4/6. Now you might be saying, hang on, you can simplify that. Let's just leave that for a minute. We'll come back to it, I promise. Let's look at the subtraction method. So we have 28/6. And we're going to take away 6/6. We're going to take away a whole. That will leave us 28 minus 6 with 22/6, which is enough to take away another whole. So take away 6/6. And 22 take away 6 is 16/6. We can take away another whole, another full amount. That leaves us with 10/6. That's more than 1, so we can take away another full amount. And when we do that, it leaves us with 4/6, which is less than a whole, so we're done. If we add these together, 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, and 4 sixths. I almost forgot the whole number 4 in doing this. 4 and 4 sixths. All right, we got confirmation. Let's try our last method, which is the standard algorithm. It's to divide the numerator by the denominator. Numerator divided by denominator. 28 divided by 6. Well, 6 goes into 28 4 full times. That's 24 with 4 left over. 4, this 4 right here, this 4, the full amount, 4, and left over 4 parts out of 6. All right, let's go back to that simplifying. You were probably saying, but wait, you can simplify that. I can. I want to see it this way first, but then I can say, well, that's the same as having 4 and 2/3, which might make you wonder, well, wait a minute. Could I have done something with the 28 sixths to start with? I don't know. Let's see if that would work. Let's say you had started with the 28 sixths, and before trying to turn it into a mixed fraction or a mixed number, let's say you decided to simplify this. Well, we know that 28 and 6 are both even numbers, so we can divide by the number 1. Remember, we're always dividing by the number 1 when we're simplifying, in the form of 2 over 2. 28 divided by 2 is 14. 6 divided by 2 is 3. Would you go ahead now and do the same 3 methods, the rectangles, the subtraction, and the division, with 14/3? Try that out. Let's see if we get the same answer. All right, so here are my rectangles. Remember, each of these rectangles is made up of 3/3, and 3/3 is equivalent to 1 whole. So I need 14/3. 1, 2, 3, 4, 5, 6. There's another whole. 7, 8, 9. There's another whole. 10, 11, 12. There's one more. 13 and 14. The last one only covered 2 out of the 3. If I add these together, I get 1, 2, 3, 4, and 2/3. Hang on a minute. Oh, look at that from my previous problem, 4 and 2/3. Let's try the subtraction method. I've got 14/3, and I take away 3 of the thirds. I take away 1 whole. I am left with 11/3. Let's take those away. Let's take 3/3 away. There's another 1 whole. 11 minus 3 is 8, and I've got 8/3, from which I can take away another 3/3. So I take 3/3 away. That's 1 whole. And I have 5/3. And I can take 3/3 away from 5/3. There's another whole. Take away the 3/3. 5 minus 3 is 2/3 left. So that's less than 1. So I bring it down. 1 plus 1 plus 1 plus 1 plus 2/3 is 1, 2, 3, 4. And, no surprise, 2/3. So far, this is working out. So far, I've got 2 different methods. Now let's try the standard algorithm, the division. I'm going to take my 14. I'm going to divide it by 3. 3 goes into 14 4 times. That's 12. With 2 left over, there are 4 and 2/3. And just in case you'd like to see them kind of side by side, here is the previous version where we worked with the 28 sixths without simplifying it. Here's the 28 sixths simplified, dividing by 1 whole in the form of 2 over 2 to get 14/3. And notice we get the very same answer in both cases. 4 and 2/3 simplified are 4 and 4/6 to 4 and 2/3. All right. So you won't always use all three methods. You won't always use the rectangles, the subtraction, and the standard algorithm. You'll get to a point where you just use the standard algorithm. Again, it's important to know why it works. And here's the why it works. All right, thanks for listening. And you're going to have some more problems to practice with. So good luck with those and really take your time to do it well.